Okay, folks, section 11.9, multiplication of binomials containing radicals. Let me move that over a bit just so you can see it. There we go. All right. Look, we don't do anything different with this than we would normally. We just distribute, okay? So in example number 1, it says simplify the quantity 6 plus square root 11 times the quantity 6 minus square root 11. So I'm going to take, going from left to right, I'm going to take this first term and I'm going to multiply it by 6. All right, so 6 times 6 gives me 36. But remember, it also has to be multiplied by minus root 11. So that's going to give me negative 6 root 11. Okay. Then I'm going to multiply the square root of positive square root 11 times 6. Okay. So that's going to give me plus 6 square root 11. And then I'm going to multiply positive square root 11 times negative square root 11, which is going to give me negative square root 11 squared. Wait, when I square root, I just get the number underneath, right? Okay. So I'm just going to write negative 11. Okay. Now let's see what happens here. You'll see that negative 6 root 11 plus 6 root 11, these two things just cancel out. And they give me 36 minus 11. You guys might recognize this. This is like what we get when we multiply. These two things are called conjugates. We get the difference of two squares, right? It's going to be 6 squared minus root 11 squared, which is just 11. All right, so I'm going to get 36 minus 11, which is 25. Okay, that's it. That's it. All right, you guys are used to doing that kind of stuff. Just distribute and then combine like terms. Remember that the square of a square root is just the number underneath, okay? Root 11 times root 11 is equal to root 121, which is just 11, also known as the number underneath the radical. Okay, let's look at the next example. All right, example number 2. Now it says the quantity 3 plus root 5 squared. Okay, well that just means 3 plus square root 5 times 3 plus square root 5, right? That thing squared, multiplied by itself. All right, so again, first term, 3 times 3, 9. 3 times root 5, positive 3 root 5. Positive 5 times positive root 5 times 3 is also 3 root 5. And then root 5 times root 5 is just 5. Okay? So that's going to give me 9 plus 6 square root 5 plus 5. But look, I can put this and that together and get 14 plus 6 root 5. Done. Done. That easy. Okay? Let's look at another one, see what we get. All right? Example number 3. Okay, well this is the same kind of thing, except it has a minus in there. Oh, and look, the first term has a radical. Doesn't mean we do anything different. Okay? 2 root 3 minus 5 root 7 times itself. 2 root 3 minus 5 root 7. Okay? So, 2 root 3 times 2 root 3, well, I multiply the 2's, that gives me 4. And then root 3 times root 3 is just 3. So now it's 4 times 3. Okay? Or better yet, think about this for the moment. Let's not even do that. 2 times 2 is 4, and then root 3 times root 3 is root 9. We'll get to that in just a minute. All right? Now let's multiply this. 2 times negative 5 is minus 10. And then root 3 times root 7 is root 21. Okay. Now let's multiply here. Negative 5 times 2 is minus 10. And root 7 times root 3 is root 21. Now when I multiply here, that's going to give me negative 5 times negative 5 is positive 25. And then root 7 times root 7 is root 49. Now some of you are saying, Mr. C, why are you doing that? Okay, well, the reason I'm not simplifying root 49 into 7 yet is that I want you to see that this is 4 times the square root of 9, right? That's 4 times 3, which is 12. Okay? This combines with this and gives me negative 20 root 21. Plus, now look, this is 25 times the square root of 49, which is 7. 7 times 25 is 175, is that right? Okay, good. And then I can still combine this, and it's going to give me 187 minus 20 times the square root of 21. Can't do anything with that root 21. It doesn't simplify. Root 21 is root 3 times root 7. Can't pair them up. Just put them back together and get root 21. Okay? That's it. That is it. That's our answer. That's as simple as we can make it. Okay? All right. Let's look at this next one. If b and d are both non-negative, that means that we don't have the square root of a negative number, right? b and d, they're under the radical, so we can't have negative 2 under there. Okay? All right, so let me get rid of that. So b and d are non-negative. Okay? Then the binomials a square root b plus c square root d and a root b minus c root d are called conjugates. This is important. We use it to get rid of radicals in the denominator when we have a binomial. Remember back to example number 1, okay, we had conjugates. And I think I mentioned the word conjugate when I was talking about it, right? 6 plus root 11 and 6 minus root 11, okay? All right, let's go back here and see what happens when we multiply these things. They get rid of the radicals in the denominator, okay? So number 4 here, it says, rationalize the denominator of 3 over 5 minus 2 root 7. Well, you know we don't want radicals in the denominator. But I can't just multiply by root 7, can I? Root 7 on the top and bottom, because remember, this has to be distributed. So then I get 5 root 7 minus 2 times 7. But I've still got this radical down here, so that doesn't work. So what I do is I multiply, when I've got a binomial, I multiply by something called the conjugate. Now let me write this a little bit bigger. They've given me this fraction, 5 minus 3 over 5 minus 2 root 7. Okay? Now, because it's a binomial and it has a radical, here's what I want to do. Okay? Think of this as a quantity. I'm going to multiply it by 5 plus 2 root 7 on top and bottom. Now, the reason I'm doing that, you see it's going to give me the difference of 2 squares. It's going to square this, and it's going to square that, and it's going to get rid of the radical on the denominator altogether. Okay? Now, let's do this. Let's see what happens. Oh, too far. Too far, Mr. C. Okay. Let's distribute. 3 times 5 on top gives me 15, and 3 times 2 root 7 gives me plus 6 root 7, because I multiply the 3 by the 2. Okay? Now on the bottom, I get 5 times 5 is 25. 5 times 2 root 7 is 10 root 7. Then I'm going to get minus 2 root 7 times 5 gives me minus 10 root 7. Okay? And then minus 2 root 7 times positive 2 root 7 gives me minus 4 root 49. Right? Root 7 times root 7 is root 49. You're going to see it's going to go away. Now watch what happens. The top I can't simplify. Right? That's 15 plus 6 root 7. Done. On the bottom, I'm just going to bring 25 down for right now. Look at positive 10 root 7 and negative 10 root 7. They just go away. Minus 4 times 7. Root 49 is 7. Okay, well, let's keep simplifying. Let me scoot down a little bit more. 15 plus 6 root 7 over 25 minus 28. That's okay, it's going to be a negative, that's all right. 15 plus 6 root 7 over negative 3. I can take the negative sign and just stick it, okay, they put the whole thing together there for me. All right, I can take that negative sign that was on the bottom and put it out front. Now, something that we need to see that I don't think that they talked about in the book. Not certain, but we're going to talk about it here because I don't keep things from you, right? Okay, let's look at the top, the numerator, okay? There are two terms on top, 15 and 6 root 7. I believe there's something that goes into both of them. We need to factor that. So now I've got negative, and 3 goes into both of them. 3 times 5 plus 2 root 7, all over 3. You guessed it. We have to reduce this fraction. The 3's cancel and leave me with negative 5 plus 2 root 7. I can distribute that if I want. I don't need to. I can leave it factored like that. This is a perfectly fine answer, but I could also distribute it and get negative 5 minus 2 root 7 when the negative gets distributed in. Okay? That's also fine. Okay? Got to be sure when I get an answer that's a fraction, I have to check to see if it reduces. Okay? All right. Good job there. Let's look at the last example. All right? Easy. Piece of cake. Find the value of f of x if x squared minus 5x minus 7. Okay, if f of x equals x squared minus 5x minus 7. It says find the value of the function. Well, look, they want us, look at what took the place of the x, root 7. So if I say f of root 7 must equal root 7 squared, right, instead of x squared, minus 5 times root 7 instead of x, minus 7. Okay, let's just simplify here. Root 7 squared, of course, is just 7. Minus 5 root 7 minus 7. Okay, well, let's combine what we can. 7 and negative 7, those two things just cancel out. And I get f of root 7 is equal to negative 5. Whoa, what are you doing, Mr. C? Negative 5 root 7. Okay, just plug it in and simplify it. That's it. Done. So you need to know how to do that. Let's see if there's anything else up there that we need to do. Let's just see. That's it. You guys are done. Nice job. A lot of stuff in there, okay? So practice, practice, practice. All right. See you later.